Good afternoon, everyone. So for today, I'm going to discuss all about scatterplots and regression in correlation. But before we will proceed, let us review first what is correlation. Correlation is the mutual relationship between two or more things. But in statistics, it is the interdependence of variable quantities. Scatterplot is the graphical representation of bivariate data that is according to Kalaka in his book of Statistics and Probability. Now, so I have here an example. A college mathematics instructor wants to analyze the grades of his 30 students in English and mathematics. He asked the students to get a piece of paper and write on it their grades in these two subjects, as well as the school where they graduated from. The teacher tallied the data collected and set up 3 tables. He found out that 10 students graduated from public schools, 10 from private sectarian schools, and 10 from private non-sectarian schools. The data are shown in Table 8.8. So for the observation and analysis, how do we determine the relationship between the math and the English grades for each group of students? So since the mathematics teacher or instructor wants to determine the relationship between the English and math grades, we say that he is analyzing bivariate data because the data are coming from two variables. Bivariate data deals with two variables, either qualitative or quantitative, that can be explored to establish relationships. And one of the best methods for graphing bivariate data are the quantitative is through the scatter plot. So here is the table 8.8. So here is table 8.1. This is the English and mathematics grades of students from different types of schools. So that this is the example of a bivariate data that are quantitative. In this plot, we can see the grades from public schools or the students that came from public schools. So English grade and the math grade are shown here and is plotted on the graph. Next, we have also the grades from private sectarian schools. And the last one is the grades from private non-sectarian schools. To further understand scatterplots, I will show you a video on how we are going to analyze and understand the relationship between two variables, like the grades of the students. Let's watch this.
Welcome to our lesson on scatterplots. A scatterplot is a graph of plotted points that shows the relationship between two sets of data. There are many types of relationships that could be distributed into a scatterplot. You could have a positive linear relationship showing that as x is increasing, y is also increasing. You could have a negative linear relationship which shows that as x is increasing, y is decreasing. You could also have a scatterplot that shows absolutely no relationship, that there is no pattern, that points are just scattered all over the graph. You could also have a scatterplot that shows non-linear relationships. You'll learn about these more in Algebra 1. You can see that there's a curve So they're nonlinear because they don't form a line. So these are special types of functions. This is part of a quadratic function, and this is part of an exponential function. You'll learn about those in Algebra 1. So let's see if you can match these data sets. We have data A, data B, and data C, and we have three graphs, graph D, graph E, and graph F. I'd like you to see if you can read through the data and imagine which graph would correspond to that data if you had actual numbers. Go ahead and pause. When you're ready to come back and check your work, hit play. Welcome back. So first, let's look at the graph D. That would model the data from B, the number of siblings a person has and their age. There's absolutely no correlation between the number of sisters or brothers that you have and your age. Graph E would show the number of hours you drive and the number of miles you travel. So the more hours you drive, the more miles that are covered. That would show a positive linear relationship. Both data sets increase. Graph F would be data A, the age of your car. As your car is increasing in age, the value of your car is decreasing. So Y would be the value of your car, X would be the age of your car, and there would be a negative linear relationship. You'll be asked to make scatter plots. Here's some data that was collected from students. The number of hours that they studied for a quiz and their quiz score. So I graphed the data to see if there was any correlation. You can see that I have a cluster here. There's 3 data points here, whereas all the others are pretty spread out. You can see I have an outlier here. Somebody studied 5 hours and scored a 35, but everybody else was pretty much right along here. And you can see that this is trending in a positive linear relationship. So I can conclude that the number of hours that are studied, the higher your quiz score will be. Here's how we interpret a scatter plot. This scatter plot shows the seasons of a Netflix series. This shows the millions of viewers that are watching, and this is the season. So you can see that as the seasons go on, they lose viewership. I'd like you to think about these 2 questions. Go ahead and hit pause, look at the graph, and answer the questions. Come back and hit play when you're ready to check your work. Welcome back. So question 1, about how many viewers watched 3 seasons? So I go up to season 3, and then I go to that data point, and I go over, and I'm going to conclude that it's about 25 million viewers. We don't know exactly because there's an interval of 4 here. So if you said 26, that would be acceptable, just as long as you're using the word about so people know that you are approximating. Question 2. About 32 million viewers watched up to how many seasons? So let's go over to 32 and down to our data point, and we can say that season 1 was watched by 32 million viewers. So I'd like you to describe these relationships as positive linear, negative linear, or no correlation. Go ahead and hit pause, read through the relationships, and come back and hit play when you're ready to check your work. Welcome back. So the temperature outside and the air conditioning cost would model a positive linear relationship. As the temperature outside would be increasing, the cost of air conditioning would be increasing. The amount of screen time in a week and your shoe size, no relationship. The amount of screen time people have in a week has no correlation to the shoe, the size that they wear. The amount of gas in your boat and the time spent water skiing would show a negative linear relationship. The more gas you used, the more time you would have spent. So, as the time is increasing, the gas in the boat is decreasing, and that would show a negative linear relationship. Thank you for joining me today.
Let us now proceed to regression. Regression is a statistical technique that relates a dependent variable to one or more independent variables. I have here an example. We may want to answer the following questions first. Without using the trend line on a scatter plot, how do we predict the sales given the advertising expenses? Second question, what is the expected sales when the advertising expenses are 300,000 pesos and 370,000 respectively? Last question, what is the percent of the variability in sales can be explained by advertising expenses? So this is the formula in finding the slope of the equation. B equals the number multiplied to the summation of x and y minus summation of x multiplied to the summation of y over n multiplied to the summation of x to the power of 2 minus to the summation of x to the power of 2. And to find the y-intercept of the equation, the formula is a equals summation of y multiplied to the summation of x squared minus to the summation of x multiplied to the summation of x and y over the number multiplied to the summation of x squared minus the summation of x squared. So here is an example of the table and the data. So we substitute the slope and the y-intercept to the least square regression equation. Y equals a plus b multiplied to x. So let us apply this to the data set in this table here. To substitute to the formula, the slope b is equals to b to the power, b equals number to the summation of x and y minus summation of x multiplied to the summation of y over the number multiplied to the summation of x squared minus to the summation of x to the power of 2. To substitute, b equals 12 multiplied to 372.16 minus 16.40 multiplied to 258.60 over 12 multiplied to 25.72 minus 16.40 to the power of 2. So the answer is 5.67. So slope b is 5.67. And to solve for y-intercept, we have here a equals 258.6 multiply 25.72 minus 16.4 multiply to 372.16 over 12 times 25.72 minus 16.4 to the power of 2. So the y-intercept is 13.80. Thus, the least square regression equation is y equals a plus b multiplied to x, or y equals 13.80 plus 5.67x. And the least square regression line can be seen in the following graph. To determine the expected sales of R&B Construction Company, if advertising expenses are 300,000 and 370,000 respectively, let us solve for the least square regression equation when x is equivalent to 3. And to further understand, I have downloaded here a video from Sir Ram's YouTube of Matuklasan YouTube videos.
Hello at welcome sa panibagong video ng Matuklasan. At sa video na to, ipapakita ko sa inyo yung mga basic concepts na kailangan nating tandaan kapag ka nagpe-perform tayo ng simple linear regression. Pati na rin kung paano i-compute yung mga coefficients ng regression equation manually. Pero bago natin pag-usapan ng regression, dapat alam muna natin yung ibig sabihin ng independent tsaka dependent variable. So, kagaya ng nasabi, itong dalawang to ay variable. So, pwedeng kahit anong values na pwede natin gamitin sa ating research. Ngayon, yung independent variable, ito yung kadalasang nagpe-predict or nagpo-forecast ng possible values ng mga dependent variables. Marami kasi tayong mga variables na pwedeng tignan ang relationship, diba? At kung gusto nating malaman kung nakaka-apekto ba yung isang variable dun sa isang variable, then pwede nating i-run yung regression. So kagaya dito, alam natin na kapag yung gas price market ay tumataas, naapektuhan yung mga ibang bilihin, di ba? Kagaya ng presyo ng gulay. Kapag tumaas ang presyo ng gasolina sa pambansang merkado, possible na tumaas din yung presyo ng gulay. At habang bumababa naman ito, malaki din yung posibilidad na bababa yung presyo ng gulay. Kasi nga, 'di ba, kapag mas mahal yung gas, yung transportation ng mga goods mas nagmamahal din. Kaya dinadagdagan nila yung presyo, 'di ba? So pwede nating sabihin na yung gas price dito ay yung independent variable. Samantalang ang presyo naman ng gulay ang nagiging dependent variable. Sa number of students din, tsaka sa number of needed teachers. Siyempre, sa isang eskwelahan, kapag mas maraming estudyante, 'di ba? Possible na mas marami ang kailangang teachers, 'di ba? Kasi hindi naman kayang turuan ng isang teacher yung napakalaking class size, 'di ba? Possible pero mahirap, 'di ba? So kung ideal talaga na class ang pag-uusapan natin, nakakaapekto yung bilang ng estudyante dun sa kailangan na teacher. Ganon din sa temperature reading tsaka electricity bill. Kadalasan napapansin natin, ewan ko lang kung napapansin nyo, no, kapag summer o kaya mainit ang panahon, pwedeng yung kuryente natin ay tumaas kasi nga, no, mas nangangailangan tayo ng electric fan o kaya lagi tayo naka-turn on sa mga aircon, 'di ba? At sa ibang appliances. Kaya possible na tumaas yung konsumo natin, 'di ba? At kapag ka naman malamig yung panahon dahil hindi tayo nangangailangan ng electric fan at ibang appliances na pangpalamig, possible na bumaba yung electricity bill. So again, ito na naman yung independent variable natin at ito naman yung ating dependent variable. At sa temperature reading naman, ganun din, no? Pares lang pala itong nasulat ko, so hindi ko na pala di-discuss yan. Kung baga, props lang pala to, ano? Anyway, yung pinag-uusapan natin ay simple linear regression. So, tinatawag itong simple o kaya single regression kasi yung bilang ng independent variable na ini-investigate natin dito ay isa lang. 'Di ba? Pero merong mga tinatawag na multiple regression. So, kung nag-investigate tayo ng more than two independent variables or more than one rather, no, na independent variables, chine-check natin yung possible effect ng mga variables na to dun sa ating dependent variable, then nagkakaroon tayo ng multiple regression. At heto na nga, ang regression analysis ay ginagamit natin kung gusto nating ma-estimate yung possible effect ng independent variables sa mga dependent variables. So, dito nakalagay one or more predictors. So, yung predictors dito, ito lang yung independent variables sa pinag-uusapan natin kanina. At samantalang yung response variable dito, ito lang yung dependent variable. Okay? So, kung halimbawa kanina, pinag-uusapan natin yung gas price tsaka vegetable prices, no? So, kung ipa-plot natin yan using scatterplot diagram, so dito halimbawa yung gas price, ito yung magsisilbi nating independent variable at yung vegetable price naman, okay, ito yung ating dependent variable o tawagin nating y. Pag plinat natin at nakita natin halimbawa na kapag tumataas yung presyo ng gas, mas tumataas din at nakita natin yung scatter plot na parang nakakabuo ng ganitong pattern, then possible na merong relationship talaga yung dalawang variables. At dahil increasing yung trend natin, possible na positive yung relationship nila. Kadalasan ginagawa natin ay correlation coefficient, diba, to determine the relationship. Pero hindi natatapos dapat doon. Pag nakita natin na merong relationship yung dalawang variables at kung gusto mong malaman kung may epekto ba yung independent variable dun sa dependent, pwede tayong mag-run ng regression analysis. Okay, so dito may nakalagay regression line. Kung matatandaan nyo kanina, ang sabi ko, ang topic natin ay simple linear regression. So, pumapasok yung term na line kasi kung mapapansin nyo, may possibility na parang hinahanap natin yung possible best line of fit na tinatawag. Okay? Ibig sabihin, ito yung parang pattern or straight line na sinusundan ng mga plots natin dito sa scatterplot. Okay? At ito yung ini-estimate natin sa regression. At ang tawag natin dito ay regression line. Siyempre, pwede nyo sabihin sa akin na, sir, pwede namang iba-iba yan, di ba, na lines. Oo, pero ang ginagawa natin, yung pinaka-best fit, kumbaga, ang hinahanap natin dito. At yun ang nagiging function ng formula ng regression analysis. Sa algebra, kung natatandaan nyo yung mga topics sa functions, nire-represent natin itong line using slope-intercept form, di ba? Kumbaga, ito yung y-intercept natin, ito yung slope ng line na to. Okay, tapos ito naman yung dependent variable, tapos ito yung ating independent variable. So, dito sa regression equation, okay, it's in the form of slope-intercept din. So, itong y prime, yan yung ating dependent variable. Yung x dito, yung ating independent variable. Ito naman yung a, no, yung intercept natin, at ito yung b, yung coefficient for the independent variable. At ito yung formula na gagamitin natin, okay, kung gusto nating malaman yung value ng a at saka b. Okay? Ngayon, bakit sa regression equation or sa regression analysis ay kailangan ng regression equation? Kasi nga, in-estimate natin yung predicting capability or power nung independent variable. At kung gusto nating ma-predict yung possible na dependent variable given an independent variable value, pwede natin gamitin itong regression equation. Bigay tayo ng example para mas malinaw. Teacher Coro wants to see how the number of absences of a student affects the student's final grade. So, naisip siguro ni Teacher Coro na nakaka-apekto yung number of absences dun sa final grade ng mga students. Ngayon, halimbawa meron tayong 6 students at ito yung mga number of absences nila at saka yung kanilang final grade. Ngayon, ang una natin kailangang ma-determine dito, alin dyan ng independent variable at alin naman yung dependent variable. So, kung mapapansin natin, ang tinitignan natin ay yung number of absences nakaka-apekto sa student's final grade. So, ibig sabihin, yung ating independent variable ay yung number of absences. At ang ating dependent variable naman ay yung final grade. So, ibig sabihin, ito yung x natin, tapos ito naman yung y. Kaya naman, para magamit natin yung formula, kakailanganin natin itong table na to para mas madali yung ating computation. So, kung mapapansin nyo dito, yung x, sinulat ko lang siya, ito, vertically. Tapos, itong y, ganun din, yung final grade. So, tandaan, ito yung number of absences, yung x, tapos yung y naman para sa final grade. Yan, markahan natin para hindi tayo nalilito. At syempre, para makuha natin yung, or magamit natin yung formula, kailangan hanapin lang natin yung x squared value for each at saka yung x times y. Okay? So, anong ibig sabihin na x squared dito? Ibig sabihin, kailangan lang nating i-square yung 9 dito. Okay? So, gagawin natin yun sa lahat. 9 squared here. Gin-square natin yung 9 dito. Nandito sa x, the answer is 81. 11 squared is 121. 3 squared is 9. Okay? Tapos ito, 0 squared is just 0. 7 squared is what? 49. Yes. And then, 4 squared is what? Yes, it's 16. Okay? So, pagkatapos nating hanapin yan, yung x times y naman. So, ang ibig lang sabihin nito, x times y. So, 9 times 65 tayo, the answer is 585. Then, 11 times 70, the answer is 770. 3 times 90 is 270. At 0 times 92, of course, it's 0. Tapos 7 times 75, that's 525. Ayan. Tapos yung 4 times 84 naman, that's 300. 36. Pagkatapos naman, dun sa formula, makikita natin na may mga nakalagay na summation, di ba? So, kung nalilito kayo, kunin nyo lang lahat ng total ng 4 columns na to at yun na yung mga inahanap natin na may summation values. So, yung sum ng x, ibig sabihin, i-add mo yan, 9 plus 11 plus 3 plus 7 plus 4, which is equal to 34. Ganun din, kunin mo lang yung sum ng lahat ng values na to sa y, you'll get 476. Dito naman sa x squared, pag kinuha natin yung summation yan, or total, it's 276. Dito naman, 2,486. Kung matatandaan nyo, dun sa formula, kailangan lang nating hanapin yung dalawang coefficients, yung a at saka b para sa ating regression equation. So, yung a muna yung hanapin natin. This is just equal to summation of y. Pag sinabing summation of y, ito lang yon, yung total ng lahat ng values sa y, which is 476. So, ilalagay natin dito, 476. Next naman, summation of x squared. So, yung summation of x squared, ito, tignan nyo lang x squared column, tapos yung total niya is 276. At yun ang ilalagay nating value dito. Next naman, minus summation of x. Ang summation of x ay yung summation ng column x, which is 34. Okay? And probably, alam nyo na yung summation ng xy, ito yun, 2,486. Ayan. Siyempre, lahat yan ay i-divide natin dun sa n. Okay, so yung n natin dito ay yung bilang ng sample natin. So dito meron tayong 6 students, 1, 2, 3, 4, 5, 6. So yung ating n is 6. Ayan, so lalagay ko dito 6 times summation of x squared ulit. So yung summation of x squared is 276. Minus summation of x, which is 34, summation of x yun, di ba? 34, tapos square nyo yung value. At yung value na dapat makuha natin, of course, is 93.704. Rounded to 3 decimal places na lang ginawa ko. Okay? Now, nahanap na natin yung coefficient na A. Sunod naman yung coefficient na B. So, sabi sa B, n naman, so which is 6, tapos summation of xy. Ang summation of xy natin ay 2,486. Minus summation of x, which is 34, ayun. And then, times the summation of y. Summation of y is 476. At lahat yan, i-divide natin dun sa 6 times summation of x squared, which is 276, minus summation of x, which is 34, quantity squared. By using your calculator, ang value na possible na makita natin ay negative 2.536. Ngayon, possible ba talaga na magkaroon tayo ng negative values for the coefficients? Siyempre, pwedeng-pwede. Kasi dun sa equation natin, di naman yan nililimit yung sign ng mga coefficients. At dahil nga nakuha na natin yung value ng x tsaka y, ano na ngayon yung ating magiging regression equation? Okay, so dun sa regression equation natin, kailangan lang natin gamitin yung formula ng y prime is equal to what? Ax or a plus bx. So dito, yung value ng coefficient na a is 93.704. Tapos, may nakalagay plus bx. Ngayon, kung mapapansin nyo, negative kasi yung b dito, no? So, lagay ko na muna. Sige, yan. Para mas mapakita natin. Then, x dyan. So, kung mapapansin nyo, negative ito. So, pagka inoperate natin dun sa plus sign yan, magiging minus na yan. So, we have 93.704 minus 2.536x. At ito ngayon yung ating regression equation. Ngayon, ang mahiwagang tanong, paano ginagamit yung regression equation na yan? Kung mapapansin natin, no, pwede lang natin gamitin yung regression equation pag napatunayan nga natin na related talaga yung dalawang variables. Kaya kadalasan, bago tayo mag-perform ng regression analysis or bago natin i-compute yung regression equation, dapat hanapin nyo muna yung Pearson R correlation coefficient o kung anumang correlation technique ang ginamit ninyo. So, pag kinuha natin yung correlation yan, the value will become 0.94. Okay. Dali, napasobra ako. So, negative 0.94. So, itong coefficient na to ay mataas at negatively related sila. So, ibig sabihin, possible na pagka yung abscesses ay tumataas, bumababa yung grade. Pagka naman na ang nangyayari ay bumababa yung number of absences, yung final grade mas mataas. Ayun dun sa observation. Okay? So, ibig sabihin, napatunayan natin na correlated siya, tapos hinanap natin yung regression equation. So, ibig sabihin ngayon, pwede natin gamitin tong regression equation para makapag-predict tayo ng mga possible values na wala dito. So, ang ibig ko sabihin, kung dito, 0 ang lowest dito, di ba? So, 0, at ang highest ay 11. Okay? Pwede akong pumili ng number between 0 to 11 as the value of x para ma-predict ko yung dependent variable, y. So, ito yung range ng x. So, tama yung narinig nyo, no? Kinukuha dapat yung minimum tsaka maximum dun sa x natin, dun sa variable x, para malaman natin yung mga possible values na pwede natin gamitin sa regression equation. At kung mapapansin ninyo, wala ditong 5, di ba? What if 5 yung number of absences ng student? Ano yung possible na final grade niya? So, using the regression equation, pwede nating ma-predict yung possible value ng y based dun sa sample size natin. So, dito, magiging y prime lang equals 93.704 minus 2.536 at yung value ng x natin ay 5. Kasi nga, walang value dito na 5, no? So, ano kayang magiging possible grade ng student kapag ka 5 yung number of absences niya? At ayon dun sa formula natin, ang makukuha nating value dyan ay 81.024. So, ito yung possible na grade ng student na magkakakommit ng possible na 5 absences, no? O kung halimbawa dun sa sample size natin, merong dumagdag na 5. According to our regression equation, no, ito yung possible na grade niyan. At ayan na nga. Ilan lang ito sa mga gamit ng regression analysis. At pwede nating i-perform ito sa mga statistical software kagaya ng SPSS at saka ng Microsoft Excel. Thank you for listening and see you in